on to challenge 2 in Code Wars, and this one's entitled Disemvowel Trolls. It's a pretty savage title. Trolls are attacking your comments section. A common way to deal with this situation is to remove all of the vowels from the troll's comments, neutralizing the threat. Your task is to write a function that takes a string and returns a new string with all the vowels removed. For example, the string, "This website is for losers, LOL," would become, I won't attempt a pronunciation of that, but you can see all the vowels are removed. Notes. For this kata, Y is not considered a vowel. We know that Y is sometimes considered a vowel in English, and to simplify, they're throwing that out. We should also note that there are case differences in this example that we will want to preserve. So, capital, uppercase and lowercase mixture there. So we won't disrupt that. We'll head over to the kata, the challenge, whatever you want to call it. At this time, as usual, you should pause the video and make an attempt at this, and then resume when you're ready, and we'll go into a solution. So, we will start, and for my solution, I'm going to make a list of the vowels, and we'll see why this is handy soon. I'll call it vowels. We'll make a new list of char, it's a character, and we'll initialize it with the vowels A, E, I, O, and U. Notice I'm using single quotes with these and not double quotes. Double quotes would denote a string, and since I'm using the single quote, these are chars. So I'll close that with a semicolon. And then, actually, on the point of us having uppercase letters to deal with too, you can imagine we're going to be doing some comparisons against our collection here to determine what is a vowel and what is not. I'm just, for simplicity here, to keep things short, I'm going to also write out the uppercase vowels. I'm sure you could come up with a way to manipulate the case so it's all upper or all lower, possibly. You just got to make sure your output has the original case. If you want to try and do something like that, by all means. So there we have the lowercase and uppercase vowels. We omitted Y like they told us to, right? So how do we process this input? Our input is called str. That's how we're going to reference it. I'm going to be using some link methods, so I'm going to bring that library in. And it has a very useful method, link does, that you can call on collections that are enumerable, like list is. If we went to the Microsoft doc page on list, you would see that it implements the IEnumerable interface. We've looked at that in other videos. We could do it again. People have requests for that. So I'm going to use a link method here that essentially acts as a filter. So what I'm going to do is take string, which can be thought of as a collection of chars or characters. That's what strings are. You can think of it almost like an array of characters. And so with that collection, I'm using this link method called where. And I like to think of where as a filter, where you provided a condition and it's sort of running that condition over every element in the collection. I know this is a string, but bear with me. Try to think of it as a collection of these characters in any string. If I typed out the word hello, you could think of that as 5 chars, H-E-L-L-O. You could think of them as separate characters. So whenever you run these methods on these collections, they're going to process each element in turn, one at a time. And then I'm sort of filtering out in here with whatever I put inside the where clause. And I'm going to use a Lambda function to do this. We've talked about that, but I don't mind answering questions about that if you have any. And this Lambda is a handy, very short way, a compact way of defining a function. And we sort of use it when, you can think of it almost like a one-off or kind of a throwaway function that you just kind of use for one purpose. If we were going to use it for many different things, we would go to the trouble and write out a full method like this is, right? This Disemvowel is a method that with a signature that we're used to seeing. And if we used ours, we would write out one proper like this. But we're just going to use it once here in our filter to get rid of the vowels. So this Lambda syntax, it goes something like this. You're going to have this, I'm making almost, it looks like an arrow. I'm using the equal sign and the greater symbol. And to the left of that, you're listing your parameter names. So that would correspond to, imagine this right here, string str, right? That's a parameter. So to the left is my parameter. Notice I don't have to provide a type here, right? It's implied by string because I called the where method on the string, so I can infer that I'm dealing with characters. I made up this ch. You could put anything you wanted in here. You could put n. You could put, shut up in here. You could put whatever you want. I try to make them meaningful. I use ch because it reminds me of char, but you could put letter or whatever makes sense to you. And then, so that's my parameter. And then on the right side of the arrow is, you can think of that like the body of the function. That's this part right here. And it could be multiple lines. I won't need to do that here, but you could. And so then you just write out whatever you want to do. And you can refer to this variable that you named here. In my case, it'll be ch, so I can use ch in the body of this Lambda function. And let's do that. So I'm going to say vowels, and here we'll invoke another handy link method called contains. And that works in a way that you would probably guess. It'll check if a collection contains whatever value you pass to it. In my case, I want to see if it contains this ch input parameter variable I made, right? So if it was going through that hello, it would take h first. It would see if vowels contains h. No, it doesn't. So in this case, I'm calling contains. We actually want the negation of that, right? Because we don't want vowels. So I'm using this exclamation mark to filter out vowels. So if it does, if vowels contains the letter, that means the letter is a vowel, right? And we don't want vowels. So whenever vowels come up, I want this thing to return false. This is called a predicate. And so it'll process and just grab the letters that are consonants in our case. That's what this will do. And then finally, the way these link methods work, it's going to return this kind of generic enumerable collection. I'm going to convert that to an array. They let you do that with this method. So that takes it from this very general structure to specifically an array. And from that, from an array of characters, I can actually construct a string from that. So I could say string no vowels, right? I could say new string. And if you look at the constructor in the string class, you'll notice that one of the overloads, you can pass it an array of characters, and it can construct a string for you based on that from a character array. So this right here at this point should have what we need in there. And if you wanted to check, this is kind of a short example, we could just run it, but let's let you see some output. Console write line, we'll just say no vowels, just put in whatever the content is. This is going to tell us we're wrong because it's just taking the input and returning it, but that's fine. I want it to be wrong right now. I just want you to see what we're getting from this statement here, running this filter using our vowels collection to filter out vowels and making a brand new string out of that. So we'll run the test just to see what we're getting. Let's try that. Okay. Oh, sure. So here we go. The typer namespace list could not be found. Feel free to pause the video and try and solve that problem. If you're ready, and you remember from the last video, we need another library to access list. It's part of system collections, and we're using the generic version. Remember these brackets here? We got char in there, so this is the generic form. Close that. That should get rid of that error. So let's go beyond that. Solution bool does not contain a definition for to array. Excepting first argument type bool could be found. Let's see, what did I do here? Vowels contains. Oh, you know what? Yeah. So we had a problem with parentheses, right? So that's a problem. You start writing some of these lengthy lines, you miss stuff like that. Notice that I don't want to convert the answer to an array until I've run this full filter, right? So this is my actual filter. This part that I've highlighted returns the collection. And then with that collection, I want to turn that into an array. So I use this parenthesis to group that section. See how it closes with this. So, yep, made a little mistake there. Keep an eye on your parentheses. Okay, so that's right. We expected it to fail because we're just giving them the output back. But let's see what we got in our print statement. See, this is us in the log. We got this website S for losers lol. And look, that matches exactly with what is expected. So I would think that if we just return this no vowels, or in reality you don't even need to waste time making a variable like this, we could just return the new string itself. That should work out, at least for this test and hopefully all of them. Notice that there was an exclamation mark in this problem, and that didn't cause us any trouble. Vowels didn't contain an exclamation mark. It's only looking for these letters, so no problem. Let's go back then and comment. Instead of returning, let's just do it like this. They wouldn't let me do the shortcut. No problem. Trying some Visual Studio stuff there. Okay, so we'll just return the new string then, and we'll test. Looks good. You've passed all tests. We could run attempt. Again, that should go against the larger suite. And it looked like it passed. Multi-line string, one more for good measure. Okay, cool. And you could go through and look at this. We took our debug statements out so we don't get anything there. That's fine. That looks good. I'll go ahead and submit this. I'll talk a little bit more. I'm going to take you over to the doc page where we can try and make some sense of these in case you may be coming into my channel on this thread for the first time and maybe you haven't heard me talk about that. So if you are comfortable with these, feel free to terminate here. Otherwise, we'll go look at the doc page where you can kind of learn how these things work. So if you're still with me, this is enumerable where, and as I mentioned, list implements this enumerable, the IEnumerable interface, so you can call this where method on it. And try not to be intimidated. There's a lot of alphabet soup here, right? Like some of this stuff looks intimidating when you're new. You see all these generics and IEnumerable, T-source, oh no, double generics. Oh God, you know, you start getting scared. You go read a bunch of technical jargon that doesn't make sense. You know, what the funk down here. So don't worry about it. You don't have to understand everything on the page at first. The more you read these, more of it becomes comfortable to you, and it doesn't look scary over time. But just be okay with it if you don't understand something. We'll talk a little bit here about it. The overloads are when you have multiple versions of your method with varying parameters. You know, if you look at what's inside the parentheses on these, you'll notice they're slightly different. And then we'll go down to nice short description, filters a sequence of values based on a predicate. A predicate's a fancy word for something that returns a Boolean, you know, to true or false. It's that filtering condition, I like to call it. And then you'll notice, despite this being a very long method declaration, you can see that, you know, it's going through all these libraries, accessing the content there. We call our method where. And then something weird about these are extension methods, and these are probably new to you if you're a beginner. And it really throws you off. You see this in the method signature, and you're like, whoa, wait a second. You know, it's supposed to be a type and then a parameter name. What's this thing? And what you can think about it, a way that I think is easy to think about, is imagine that this is referring to the method itself. So you're not actually passing this as a parameter. You can ignore that and you'll just be passing the predicate. And the this just refers to the object that you're calling where on. In our case, if you remember in our example, it was a string object, right? And a string is a collection of chars. So we did string dot where. And so then we had to just pass the predicate. But that's sort of how this works with those are called extension methods, where you can kind of extend the behavior of a class. So if you see the this, and it always happens in the first parameter, just know that you're not actually passing a source here and a predicate. It's just saying you're calling this method on this type. You'll say this type dot where. So that's all that means. Looks terrible. But yeah, predicate, a function to test each element for a condition. We talked about that. In our case, we wanted to check each letter if it was a vowel. And then probably the best part about the docs page, if you just search Microsoft Docs, you're going to find this, by the way. It's very easy to find. You type that in Google, you'll get there right away. So don't stress if you don't have the link written down. But these examples are oftentimes, I'll just go there first to try and understand something very quickly. And look at this, they give a nice example with a list of strings that are fruits. They list a bunch of them, and you can see their query. They took this fruits collection that they defined up here, and they're using where, like we did, and then drop that Lambda function in here, right? They chose to name their parameter fruit, which is an outstanding name for a collection of fruits. And then the body of their Lambda is this, what they call a predicate. It just returns true or false, right? If you take a number and check if it's less than another number, that returns true or it returns false. So there's your predicate. And then they're kind enough to show you what the output would look like. You can see those are all less than 6 letters. But this is a really quick way to grasp. So especially when you're new, I would say maybe just go right down to the examples section and you can get a nice quick idea of how you can use these things. So yeah, and then you could look at, they usually list the different overloads in order. You can see now it's highlighting this because we're in this section. If we go up, we were on the first one. But yeah, that's what that is. And then you could go to the search bar, right? There was another one we used. I think we had contains, right? Let's see if we can find contains. Enumerable. Well, you know what? Maybe we can expand. Let's go. Here we go. See? So we were already in Notice we already expanded enumerable and we were in the methods section. So yeah, you could see contains in here. And you can basically do the same thing. You know, you get your quick little down and dirty explanation. Determines whether a sequence contains a specified element. We saw that work. Again, look at, we called the contains method on a collection, right? Remember this again, you're not passing this first parameter. That's just saying you can call contains on this type, and we gave a value. It was ch, it was a char in our case. So yeah, and it should say, yeah, we can go down to the examples. Value, see, it returns a Boolean. That's what our predicate had to do. True if the sequence contains the element, and false if not. There you go, predicate. And again, nice cool example, again with fruits. And you can see if it contains fruit, which is mango. And it does contain mango, you see in the output. So yeah, you'll probably see me using a lot of these kind of link methods. We won't go over all of them. I'll certainly go over any of them by request. But yeah, you can get comfortable. The docs are your friend. You're going to want to be able to look up all of these and read through them. You know, if you don't understand it all, just press that I believe button and carry on. And I promise you that over time, these things, you start to gel with the format, and it looks very nice. It looks like something that actually helps you instead of something that is trying to make your life difficult. So yeah, I think that covers everything for this challenge. Yeah, I'll go ahead and submit this one. I'll remove that. We don't need it. And then again, you know, I don't prepare much for these. I look at the challenge and think of a general way. So if you remember from the first one, when we submitted, they show you solutions submitted by other people. And so that you'll probably can find some really good stuff in there. Feel free to look those out. I'm just trying to, I kind of wing this in a way so you can kind of come along with me on how to think about some of these problems. They're not totally winged, but I'm definitely not building the most clever solutions because I'm not investing the time to think about those things. And certainly there's just people out there that are extremely talented that could think of things that I would never think of. So that's the other factor to that. But yeah, otherwise, thanks for watching, and hit me up with questions. You know where to find me. Otherwise, we'll see you in the next video. Thanks.